Hello, thanks for joining me on this video about the surfaces. It's the fifth video on geometry and introduction to all of the ways you can make geometry in BitByBit. So we already discussed the points, lines, polylines, curves. It's all of those tutorials were not too deep, but really to the point, I suppose. And today we'll be going through the surfaces and how we can create those. Surfaces are more complex than curves in that they are entities that have area, of course. And you saw with curves that there were quite a few methods to be applied on them. The list was vast, and so the surfaces, while this list is not too big, but they have many form surfaces, and they can be created in multiple ways. We will pick a few examples today. We will be making the we will be creating the surface by lofting the curves. Because that's one of the most flexible solutions to create surfaces. And this we will try this method, but we will not touch upon that one because that's quite a heavy mathematical definition of the surface that would take us too long. It would not be very meaningful to discuss. Also, the surfaces that you see in this in the subcategory, like we can create the spheres, cones, cylinders, extrusions, revolutions, and sweeps. You can find the example in here how to create those. So it's called the standard surfaces example. And also, I already made a video that walks you through all of those types of surfaces and how they work. So that's why today I decided to focus more on this, on these two surfaces, because they will provide us with better insight of flexibility of the Nurbs surfaces and how they behave and work. So without further delay, let's just begin, and let's drag and drop this component into the canvas, which should create the surface by lofting the curves of degree. But we don't yet have any curves, so first we will have to create those, and then we'll be able to make the surface out of those. And one thing to note is that we probably need, of course, the grid first, and let's then begin by making the curves. All those videos I start with nothing inside the canvas, so you can follow me from the very beginning how I do things, so you can learn better and understand the principles. And I'll be making the curves through points, as I did in the explanation video about the curves, how that works. You can find the information there, but we will repeat the same approach now, but we will go on further to lofting those curves. So we will make quite a few of those curves and we will loft them, so you will begins understanding how the surfaces can be created from the framework of curves. And also we will need the list of points to create the curve itself. For curve, and let's create that, and let's set this list to be a list of multiple items like that. And you already saw me do this in the previous tutorial. I will just make 6 points for this curve. And to do that, I will use the create method of a point. So it's gonna be 0. I'm just copy pasting everything, so it's gonna be a bit faster. And let's see. So now let's also immediately draw those points so we can orient ourselves better. What are we doing? Sorry, I will use the right component for the job. And so this we'll have to wait. I'll delete it for now. And let's find the variable that we have to draw. And let's click play. And now, as you see, nothing has happened, which is probably correct, but I'm not sure if it's... yeah, so it's really hard to see. Let's make this bigger to 20. Let's make this red. And you'll see that all of the points that I have now are on 0, 0, 0. So that's correct. Let's begin moving them further and further away, like this. And then this one will have the Z of 6, and Y can go back to 1, and let's do 3. And let's see what we've just created. So maybe this will have to go up again and to be on 8, for example. So interesting what that will do. And let's see what points did we create now. So this is the path of the curve that we can visualize. Let's now, so now we have points, we can create the curve through those points, and we can also draw the curve with this component. I'm going quite fast now because we already talked about these things in previous tutorials, how to make the points, the lists, and the curves. So I hope you can still follow, and the moment we will arrive at surfaces, I will slow down and we'll begin explaining a bit better the ideas. So go through points. So let's pick this variable and plug it into this curve through points component, and let's see what kind of curve do we have now. Well, that's quite an interesting curve, I would say. I like it, so let's go on with that. And now the more interesting thing would be, of course, to create another curve, because how lofting works is that you create two curves different from each other and you make the surface in between those. So there are many ways that you can achieve something like this, but I think in our case we can just go with a manual approach, and because that will provide us with a bit more interesting result, hopefully, because I can then edit all the coordinates myself, and it will be just easier. So this is now of course all on 0 x, but if we want to we can just make a variable, for example, let's call it offset x, and let's create that, and let's set offset x to be oh yeah, look, I will do the math. Let's put it on 5, and let's use this variable instead of the x. I will just copy paste this variable 5 times. No, this one, Control C, Control V, Control V, Control V, Control V, and we have it. Now we can use it in multiple places, and it will always be updated by the same number. Oh, that I did wrong. I have to watch what I do. Okay, So now we have this other curve that we will name list of points for curve 2, and we will set this new variable to contain this list. And of course we can, if we want, we can visualize that as well, and we can also draw that curve and see that it's exactly the same curve but then offsetted quite a bit. So that's quite easy, but I think to make a result of the surface nicer, we can play around a little with those constants and see what that gives us. So this is okay, I suppose. Maybe let's open it up a little by having by not going back so much. Like, let's go back a little bit with that point, but not too much. So now it's opening up, and maybe it's a good idea to make the surface a bit I don't know, longer. Like let's start at z of 3 minus 3, sorry. So like this. So the curve itself becomes a bit bigger, and our framework is beginning to take shape. Of course, the points look now quite a bit ugly. They're really big. You can also navigate through all the inputs with tabs, so that's quite nice in those components. Okay, so that's our model now. And already with 2 curves, we could actually create the surface in between those. And let's do that so that you would understand how the lofting behaves when you have 2 or more curves. So first let's do 2, then we will add additional curve, and we'll see what that what the effect of that is. So to create the loft, we go into the surface, we click create, and this .create method just has a standard creation methods for Nurbs surfaces. These are not a standard form surfaces like sphere or cone, so let's just pick this method. And now, because this component expects the list of curves, you can imply that by the wording surface by lofting curves, so it expects multiple curves. We can give him the list with 2 items, and to do that we have to delete 1 item from the list here, like that. So you just drag and drop it out, and this is now empty list, but we will fill it with our variables. So list of points for curve and list of point for curve 2. And let's put the degree of the surface to be 3, and let's also now draw the surface. In order to do that, we just plug it in like this. We can make it a bit lighter, and maybe let's make it less visible so that other geometries okay. Yes, so that's something bad. Check if there are no disconnect or misconfigured components on your canvas. Is not a function. Okay, so I know exactly what's wrong now. There's a mistake here, because I said that I'm creating a list of 2 lists of points and not the curves. So I skipped a step where I had to create the curves and I had to assign them to variables. So I'll do that now, and you can follow if you want. So let's do the curve 1, create this variable, and create a new variable curve 2. Let's add that, and now we can begin doing things like that. So curve 1 is that, and we can copy paste this, apply curve 2, drag and drop it out, and create the second curve from the second list. Yeah, okay, so this is not completely maybe logical. Let's do this like this and like this so that the first list of points goes to the first curve and the second list of points goes to the second curve. Okay, so now we're back and we can use those variables in here and in here now. So let's do that. Let's find those list of points for curve. We will not do that, but we will do this curve 1, and we will provide this curve 2, and we will do also the same for this list. So we will provide not the points anymore, but the curves. And that's it. So if all is good, we see now our surface. And that's quite a complex geometry, but it is what it is. It did create this surface between two curves exactly. So it sort of extended the loft between. So that's nice. It's not a very complicated surface, but still quite an impressive achievement of our code that we've just did. So, and you see that it's bent in many ways. It's also it's probably a revolution surface, I would say. There is a straight line going. You could find the straight lines probably going from one side to another. So, but the effect is quite complex. And also, I will create now the third curve, so you could see how we could make this even to be more interesting with 3 curves. And of course you can make as many as you want in ways that you want. Like if you want to loft 100 curves, of course it will take a bit more time, but also how you will create those curves will not be like what I do now. Probably you will have some iteration loops that are that is just making that up. And so, but let's continue and let's create a new variable called list of points for curve 3. Let's create that. Let's use this and that. Let's put this code inside here. Let's also change the offset x by another 5, so it will be 10 for the list of points for curve 3. And if all is good, it will just offset the second curve towards that direction. There's a lot of so you will get, if you're not used to this thinking of how coordinates work in space, you will definitely get used to by coding these kinds of applications. A lot of things are happening in my head, of course. I hope you can follow this. I hope it's not too magical, but it's also not too difficult, of course, if you grasp what the numbers are doing and what the code is doing. So now, just to prove the point, I will also create the variable curve 3, and I will be saving on time. I will not be visualizing the points anymore. I will be straight and create this curve 3 from the list of points for curve 3. So you will see that, and I will visualize that then. So let's do this. Let's play. You will see that I'm now duplicated this curve in here, and I will just edit it a little bit to be not as long anymore. I will put it back to 0. I will make this coordinate go out, and also I will increase the height of this whole curve. I will increase actually the height of the middle curve to be more extreme, and so it will probably form a bit more convex and concave surface. So okay, so now we have 3 curves. We can also stop visualizing points maybe, because they are not really important for the script. And just to add this new curve, let's first check what the effect is of our changes. So now the surface is still created between the 2 curves. And to just add the third one, I will drag and drop this item to the list, and I will say that I want to add this third curve here in the list. I will stop the settings, and probably now you'll begin seeing what is happening here. So I'll make this to 1. Let's pick maybe another color. Let's try this one. Okay, perfect. So now what happened is that we've just created the surface that lofts 3 curves together, and in that way we've created the model. And I think it's quite a nice model. I'll make a screenshot of that. Quite an interesting result from just playing around with numbers, of course. But the important thing to understand is that now we've made this surface which can be used again to create additional points of reference for additional geometry. And it's not very complicated to understand how this all works, but it's very crucial to read correctly what inputs expect of what kind of data the inputs expect. So if you read that it expects curves, you need to provide the list of curves, and how you make those lists doesn't matter too much as long as they are lists. So you can create them with these kinds of methods. You can create them just in iteration loops, and there are various ways to do that. It's up for your creativity to really blossom there. But now we have this surface, and I think it's a good time to look into what kind of things you can apply on the surface like that. So let's ignore those subcategories, and let's see what we can apply on all the surfaces that we can create. And you can find the point on the surface at various coordinates. You can find normals of the surface at various coordinates, but we can just also you can find, of course, closest points on the surface from points in space. So if you are somewhere here, you would find the point somewhere on the top of the surface, etc., etc. You can transform surfaces as you can transform the curves. You can get all the information about your surface by using these additional methods. But what I would like to now extract from this surface is the isocurves. And I'm thinking to do that in the iteration loop so that I would not be seeing the surface itself, but I would see all the curves going through this surface. And I'll do that by first creating the variable that will hold the information about my surface. So it's my surface created, and I'll set that to be the surface by Lofting curves. I will drop that out. Because we have those three curves, now nothing will be visualized, but we can say that we want to get the isocurve of the surface at parameter v, and I'll to hold all the isocurves, because I want to get not one, but I want to get all of the isocurves that that in a certain step. I will just say that I have isocurves list here. I will set that list to be empty in the very beginning, and I will also iterate through with the help of the loop between 0 and 1 at a step of 0.1 or 0.05 if I want to get 20 curves. And now what I can do is I can say I am adding an isocurve to the list every time the iteration runs. So we did that already with the points when we were creating the grid, and we will be inserting at the last element this isocurve, and the isocurve will be it will be created from the surface that we just attached to the surface created variable, and we can find it here in the list, and we will say that the parameter is the y variable, so we just find that also in the list of all the variables that we have, and we will be able to transform the direction of the isocurve that we want by using this flip parameter. And this is just a logical operator that should answer the question if we want that or not. So first we will say that we don't want that, and we will just extract the isocurves from the surface created, and we can now visualize those curves that we derived from the surface. So we will do this, we will draw the curve mesh, we will pick the color to be orange now, so instead of this surface we will see curves, and we will use the isocurve list variable to do that. Okay, so just to be safe, I'll export my code before I run it. I was coding quite a bit now, so just not to lose track. I will play it now, and you see that the isocurves were created, and this is quite a simple way to do that. It's going through all the points that I've asked, and you see that I can also flip this direction by using this boolean and say that we want to have these isocurves, and that's basically how how everything in BitByBit works. Those geometries that you create, you can reuse to derive various different kinds of data from them to make further manipulations on the geometry. So if you're doing structural analysis or something, that's super useful to create parametric models that are more complex than just manual, that is allowed by manual modeling. I think there are, of course, way more that we could touch in this list of all the things that we can do with the surfaces, and these lists will be growing in time, of course. But I think I've touched upon the main ideas behind the lofted surfaces. We didn't yet tried to create the surface through four corner points, but that's not really a big problem. You can look at the example here under the Street Smart category to get the inspiration how that could be done. And with that, I think I'll close this tutorial, and we'll leave space for future videos to explain more in detail what is possible with this surface category.